So my name is Juan Marcano, and I'm here to talk to you about how we're using generative AI for mobile testing to improve app quality and developer productivity, and also all the things we are doing with generative AI to improve the productivity of all of our employees. And I'm gonna show you some pretty cool demos. And if you're not a believer already, by the end of this, I'm pretty sure you're gonna see why AI is a game changer for testing and productivity in general. And alrighty, so this is me. I've been out of work for 6.5 years. I went on a sabbatical 2 weeks ago, so it was nice. And I started DragonCrawl like 6 years ago. Lots of failures at the beginning, but then lots of success in the past 2 years. And before Uber, I was teaching drones how to navigate with computer vision and reinforcement learning. And before that, I was teaching robots how to thread needles, literally like this, with reinforcement learning and computer vision as well, which didn't always work, but was pretty cool. And so, yeah, I've been teaching agents how to do stuff for the past 12 years or so. And today we're gonna talk about two of those agents, DragonCrawl for mobile testing and OmegaCrawl, which is like the all crawler. And now, so why generative AI for mobile testing? And the reason is that in traditional testing, what you do is you write a script in something like Appium or this framework or that framework, and then every time there is a change in a button or a pop-up or something small like that, all the tests break, and not because there's a bug, but simply because the app changed, and then the tests need to be updated. And at a place like Uber with 3,000 backend engineers, 700 mobile engineers, plus 300 other engineers, like myself, that amounts to 30 to 40% of people's time just on maintenance. And if that fact alone is not bad enough, another consequence of this is that because those tests would fail so much, so frequently, the SNR would be pretty low. So you wouldn't trust the results, you would always use your eyeballs, and therefore you would not be able to shoot them to the left. And finally, at a place like Uber, that operates in hundreds of cities, 55 languages, and we have like 3,000 experiments running concurrently, it would be extremely expensive to test all of that manually. Like, we would need an entire country to do that. And it would be also really expensive to write and maintain all of those test scripts. So with DragonCrawl, we fine-tune models to address those pain points. We fine-tune them so that they could get through those small UI changes to the point that they could run with a high pass rate, high SNR, and shift them to the left. And that's something that we actually did last year. And also something else is that with DragonCrawl, you configure once, you tune once, and it works in many cities and in many languages. And finally, these numbers are a little bit outdated, but the models that we started with are 1,000 times smaller than ChatGPT or 10,000 times smaller than ChatGPT. I don't know anymore. But the TLDR is that it's really cheap to scale this out. And here's how the magic happens. What DragonCrawl uses is the view hierarchy, which is a text representation of the screen, dumped into this huge XML that we parse. And how we parse, that's our secret. I cannot tell you, unfortunately. But we combine that with the goals of the test and turn that into a prompt. And that is the input that DragonCrawl gets. And then the output that we get is the actions that are most likely to take us to the end goal, to the end screen that we want to see. So for this example, right, given the goal of requesting a trip and given all of the buttons that we have, Dragon is not gonna say, close the app. Dragon is not gonna say, let's go back. It's most likely going to say, choose UberX or confirm UberX, something along those lines. So it really tries to choose something that is semantically approximate to the goal. And here's something else where we thought differently. And in traditional testing, what you do is you load a screen and you assert, or you touch a button and you assert, and those assertions tend to be based on text, on IDs, which may or may not change, right? So you may need to maintain them. And what we do instead is, as we execute the flow, we take screenshots at every step, and then we use them later to assert. And those assertions are powered by models as well. So you see over here, we produce these graphs that we call the crawl graphs. And as you see, pretty much every screen that we care about has a name. And what we do is we go screen by screen, we load the assertions that we care about, and then we execute them. So some of the assertions that we care about are, for example, we check if the content is in the right language or in the wrong language, and we file tickets. And some of the things that we check for example, in London, is whether or not we show the vehicle make and model, license plate, the driver selfie, and things like that. That is specific to London. And this is how assertions are done at Uber right now. I mean, not with the notebook, but people put in a config file the questions, the assertions that they care about. Like, hey, are we showing an ad here? Are we showing a rating screen? Are we showing alcohol drinks? So SDITs and mobile engineers at Uber are not making hacky pixel-based solutions anymore. They're not asserting based on IDs anymore. They're just asserting in plain English, which is really cool. And yes, I got one of these images from Reddit, not for myself. And this other one, yes, was produced by us. And this is in production, by the way. And now here's some of our quality wins. These numbers are from last year. And as far as bugs that we have detected, we detected 11 high priority bugs. These are the kinds of bugs that would prevent people from requesting a trip or ordering a meal or the driver from accepting a trip and things like that. So pretty destructive things. And every time one of those comes out, we lose like $2 million. And we have the data on that, which is pretty interesting. And like I mentioned earlier, we also detect if the content is in the right language or the wrong language. And we have found like 200 localization bugs. Those are very subtle. Those tend not to be like high priority. So they take like a month to get resolved. But we still found a lot of those. And I don't know if you guys are aware, but every once in a while, Uber tries to break into a new market or tries to launch in a new product or tries to launch in a new language and stuff like that. And the localization team at Uber has used DragonCrawl to launch in Catalan, Bengali, Pashto, and Dari. And the last two are pretty close to my heart because those were kind of in emergency mode in like 2021, 2022. And we did that to make sure that the Uber apps would work in those two languages because that was to help with the humanitarian crisis for the Afghan refugees. And finally, something else that we did last year was we collaborated with the chaos engineering team. And what we did was we essentially enabled Dragon to inject backend faults, meaning some aborts, some timeouts, and small things in unassuming services. And in theory, nothing should break. But the reality is that we have found 27 surprises of that severity, right? Like you cannot request a trip or you cannot accept a trip, right? And I'm pretty sure we're gonna find even more. And something that was very cool about this was that, sure, we made the integration so that DragonCrawl could inject these things, but then we had to make DragonCrawl not just fault tolerant, but fault aware so that it would know that it shouldn't just give up. It should just keep on trying. And here are some sample bugs. Here, the one on the left, classic, someone submitted a PR and they introduced a bug. The user accepts all the terms and conditions, but they cannot move forward with requesting a trip. So we detected this one before anybody else. We blocked the release and got resolved within 6 hours. Here's one of those pesky backend bugs, resilience bugs. So we introduced some faults here and there and some unassuming services, but we get this, oops, something went wrong. Please request your trip later. And it took some time to work with the backend teams to fix this. And I mentioned earlier, localization bugs tend not to be high priority, but here, what we got is DragonCrawl was requesting a trip somewhere in India. The language here was Canada. It was getting ready to request a trip, but then we got the terms and conditions in English. And well, we don't know how destructive this could have been. I don't know if we could have gotten sued because we prevented it. But yeah, we shouldn't show something legal in the wrong language. And these are productivity wins. Pretty happy about that. And here, this is a snapshot of just a month or two, so that I could talk to you about it. And the TLDR here is that pass rate is over 99%, like 99.3%, since December 2023, zero maintenance, pretty much. And over here, some of the dips that you see are, get outages. There's nothing we can do about those. Here we have a really big dip in our pass rate. And yeah, this was a bug that we detected 16 hours before anybody else. I forgot what happened here because it's been a while. And then here, there was this bug that we detected before anybody else. Actually, we were the only ones that detected it because this was a bug that would only happen in Brazil or Mexico or a couple of other places. And, because Dragon doesn't care about where it is, it just finds a path. We were the only ones testing it. And here, this is another outage that we detected. But here we were 16 minutes later than the other systems, but we're still happy about it. And now, because this is what it looks like, our SNR has been 100% since July 2024. So yeah, at the beginning of 2024, like Q1, yeah, our SNR wasn't in a happy place, but then we worked on models, computer vision models to deduplicate some JIRA rules here and there. And now every time we file a ticket, it's not a duplicate and it's something that has to be taken action on. And because of that, we don't spend time triaging. When a developer gets a ticket, it's on them. And here we have numbers about our coverage. So the first row that you see, 5 cities and 2 languages for 200 builds per day. This is what we used to do before. Now we have 30 flows. We just run them in one language on a daily basis, around 200 times per day. So around 6,000 builds per day just in Android, and then similar numbers for iOS. And then in the weekends, to get ready for the release, which happens, I don't think I'm allowed to tell you when it happens, but in the weekend, we told Dragon to go crazy. Just test in 184 cities and 55 languages to make sure everything worked globally. And as far as the developer hours saved, we don't actually know anymore because we're claiming 35,000 developer hours. But if you think about it, you have one test that can run in 184 cities. So it's 184 tests that you don't have to write or maintain ever. So we're really undershooting here with 30,000. But whatever the number is, we're really happy about. What you're gonna see here is one Dragon controlling a driver and one Dragon controlling a rider. And they don't know that each other exists, but they're gonna work together to orchestrate a trip. And yeah, we're gonna hit play. And what you're gonna see on the left is the driver. The driver is basically just gonna go online and wait for the trip request. And then on the right, you're gonna see the rider. The rider is gonna choose the drop-off location and then do all the steps it needs to take so that we can request that trip. And now here, what you saw on the left, the driver opened the trip planner, right? This is one of the artifacts of LLMs. They are a little bit non-deterministic, but that's okay. It's not really disrupting things here. And the rider confirmed the trip. The driver is going to get the request. It's going to accept it. And now the rider is going to close the app. It's going to say, I know I'm on my way. I know I'm done from here. So now focus on the driver. See, it gets a pop-up. It waits. And then it gets it again. And now it's going to say, okay, and boom. So that is exactly the type of thing that breaks a traditional test. But as you saw, Dragon didn't freak out. Dragon didn't get it right on the first attempt, but it still found a path. And now it completes the trip and mission accomplished. So what happened there? So what happened there was that, we got a screen that we didn't even know existed. And first Dragon tried to wait it out and then it didn't work. But then it says, you know what, I don't want to get stuck here waiting. So I'm just going to click OK and see if that works. And it did work. And this is to show you, this is why we have the 99% pass rate. And this is how we are resilient to those unexpected screens and unexpected scenarios. And this is why pretty much generative AI is the only way to do these kinds of things at scale. Because you need the tests to think on their feet. And now Dragon has been running, like I said, since December 2023. And a lot of people thought I was the boogeyman. I was going to destroy the SDETs and stuff like that. But here's the truth. At Uber, I have not eliminated a single job. In fact, the SDETs at Uber are now working on tools that Dragon can invoke and MCPs that Dragon can invoke. So they're working on more sophisticated cases that involve complex coordination with the backend. Like, for example, in the middle of the test, send me a discount. So Dragon talks to the backend, and then we get the discount. And it's SDETs who are working on that. And they're not concerned about their job security, because if anything, with the stuff they're doing with us, they're picking up some really nice skills that it's probably making them more attractive as candidates than they've ever been. So yeah, I don't see job losses here. And with all of those successes, the leadership team came to us and they were like, you know what? This stuff doesn't have to just stay with mobile testing. Like, what are other things that we could automate over here? And that's when we started to talk with other people that I had never talked to before. And well, I found out some interesting stuff. I found out that business development people and sales people spend 40% of their time like updating CRMs, updating spreadsheets, and just doing stuff that is not related to sales. It's not related to making customers happy. And also, there's a lot of accounts and passwords that have to be updated manually because it's really hard to automate that. And recruiters looking at calendars, hours and hours per day, use with their eyeballs, right? So, we have a very long laundry list of things to automate. And we got like one of those aha moments where we're like, you know what? We gave DragonCrawl the ability to crawl the Uber apps with an emulator. Now let's make something that can crawl anything. And we called it the OmegaCrawl. And in concept, it's very similar. We use large vision models and reasoning models so that they look at screens, decide what actions they need to take, and then they take them. And using MCPs and tool calling, we created the things that they have access to. So we give them access, for example, to Excel, or to the entire desktop, or to the bash script, the terminal, so on and so forth. And I have a couple of demos. So this one is going to be very similar to the stuff that you saw DragonCrawl do. And this is what it looks like. Well, resolution is not great right now, but you can ask OmegaCrawl in just plain English something in plain English, and then it tries to execute it. So here you cannot really see it, but I'm asking it to look for, there we go, now we can. I'm asking it to search for Greek restaurants near my house. And here, everything, you can see how it thinks on the left. So it takes a screenshot and then it says, okay, click open Firefox, because, well, we have Firefox installed in the Docker. And now it's probably going to, it's going to enter Uber Eats, and then it's going to, oh, look, this is something interesting that we got. So, we got this pop-up with cookies, I think. And, I didn't tell it what to do with the cookies, but it decided to close it. Just get through that, right? Get away from that. And now here, it entered my address, and now we have two options. We could touch the address, or we could touch search here. There's a little bit of uncertainty on what we have to do to be able to load the results. But it touched the address. It didn't touch the button, which was incorrect. But honestly, that's a problem that I created because I could have given it better instructions. I could have said, step 1, open Firefox. Step 2, put the address. Step 3, click on search here. But I gave it vague just to show you what's happening over here. So, even though the instructions were kind of vague, you see, we're not crashing. I didn't hard code a timeout. I didn't hard code for OmegaCrawl to try something else later, but eventually on its own, it says, okay, it's been enough. So let's try a different button. And yeah, it clicked on search here, and now it's going to click on the search bar where it says search Uber Eats, even though I didn't really exactly tell it where to go. And it's gonna do that in a couple of seconds. And now it's gonna type Greek and search. and we are done. So again, very similar to mobile testing or web testing. But here, OmegaCrawl was told to search for something, and at first, it got a bit of a curve. It was an easy curve, It just said got it when it got this unexpected pop-up with the cookies. And then over here, it got a more difficult curve. And first it got it wrong, but then it got it right. It took a little bit longer, but again, I could have prompted it better to get this done faster. And now, here is a demo that scares people a bit more. And here, it's gonna load eventually. But here, oh yes, and we also have it in dark mode, because why not? But here, the resolution is pretty nice, by the way. I'm asking it to write a bash script to output a random number between 1 and 9. And that's a very trivial request for me to make. I could have asked it to do, to write something that takes more code. I could have asked it to, create a spreadsheet or whatever, but I just wanted to test this out to show it to you guys. And the first thing it did was it created the script somewhere in the directory, and then it made it executable. Because again, I gave it access so that it could run the terminal. But now here I'm gonna say, hey, you know what? Run it in the terminal, like actually open the terminal so that I can see what's going on. And it looks at the screen. It moves the cursor. Well, we cannot really see it, but it moves the cursor, makes a left click. And this is heavily based on computer use from Anthropic. And now it runs the script, and we're done. Small recap over here. I asked it again, a trivial script. And then, because I gave it access to the file system, the terminal, the entire desktop pretty much, it created the script. And then it made it executable. And then it executed the script. So I gave it access to run commands for me, and it runs them. And again, it could have been something more complex. Or it could have been something to update a sheet or create a Google document, so on and so forth. But this hits the point, right? You can now have agents run commands for you while you sleep, while you do other stuff. And here's the secret sauce. Very similar to DragonCrawl. So you take the current screen and the previous screens and the previous actions. You turn all of that into a prompt. And then what we get from the reasoning model is the action to take and why. A reasoning. And now, some of the implications of what we see, right? So, same for DragonCrawl. A lot of the stuff that you saw over here is powered by MCP and tool calling. And now, we're not getting the Terminator anytime soon, but we are at a point where we have to think about what things our models have access to. So, for example, with OmegaCrawl, it has access to a very isolated Docker, compartmentalized and all of that. So we're cool with it. We're cool with it having access to the entire desktop. But if you're gonna run something like that in your entire laptop with your passwords, you have to think about it. I don't know if you would want to do it like that. So yeah, what kinds of things should your models have access to? And as you saw with this stuff, right, you can have agents running commands for you, agents doing chores for you. Well, these models are no longer just assistants or copilots, right? Like they are real force multipliers. And there are companies that claim they haven't hired humans in months. I don't know if it's true, but that's what they claim. And apparently, a good amount of companies or startups like Y Combinator, they're just using Cursor and Copilot and so on and so forth to write most of their code. And so, even though these things make you think about your job security, the trend is that there's still growth in software engineering roles. And like I said, my experience with DragonCrawl is that we haven't eliminated a single job. Actually, people just became more attractive, right? And now, what does the future hold? Honestly, I have no idea. There is MCP, there is A2A, right? where agents talk to each other and do stuff together. That's pretty cool. There's people doing stuff where you put multiple agents, so to speak, in a room and have them debate. We're gonna see a lot more of that. But something that is not really getting a lot of attention is that we're gonna have some models that are gonna be very, very powerful. And actually, some of them are already here. There's gonna be in the future, and like I said, they're already here, models where you can dump 10 million lines of code. So for my Netflix people over here, okay, there you go. You could dump 1,000 of your 4,500 micro-repos into one instance of these models. And a lot of the mistakes done by LLMs, simply because they cannot really hold into context so much code, they're gonna get eliminated. Unless the models don't really work, right? So, but assuming they work, a lot of the errors are gonna go away. And I talked with Magic. By the way, I don't work for them. I don't have their stock. There's not a solicitation, nothing like that. But they told me that, yeah, they're gonna go for 1 billion context windows and then 10 billion. And their goal is to eventually put the entire internet into context or be able to do that. You know, pretty aggressive. But yeah, eventually we're gonna have models. There's gonna be models where all of, for example, Uber's code could be in context. And something else that people are not really talking about, especially in developer productivity, because this is mostly a concept from robotics, is world models. Now, world models and the power, the methodology that they're going after is actually teaching cause and effect. Because LLMs, the word they're trained, right? Like, it's all about predicting the next token. And they do a surprisingly good job at that. But with world models, the way those models are pre-trained, they're actually gonna teach robots, hey, like, if I push an empty box like this, it's gonna move 2 feet away because of all of the physics concepts. So when world models come to developer productivity people like us, we're gonna teach them what's gonna happen to our code base when we introduce a change. So they're gonna tell us, if they have a lot of context, they're gonna tell us, hey, this change we're proposing here, this is gonna cause an outage. This timeout over here, it's gonna break microservice 1,000, right? It's gonna interfere with this, gonna interfere with that, because it's really going to understand cause and effect. And like I said, if they have very large context windows, they're gonna say that with much more confidence, much more accuracy, and they're just gonna be able to see more and more. And I think we're gonna get super linters, super code reviewers. I think, you know, we're pretty happy with the code review tools and what it's called plugins that we get from Cursor and all these places. But I think those are probably gonna go 10x, 100x in terms of accuracy. And well, we're gonna get all of that, but it's still not Terminator time. So no need to worry about it. And yeah, this is me. Feel free to reach out to me, add me on LinkedIn, whatever. And now Q&A, guys.